Hey there, kids! Welcome back to another video. This is Module 3, Lesson 4 for Eureka Math in 5th grade. And the objective today is to add fractions and then get sums, which is the answer to an addition problem. And your sum will be between 1 and 2. So you're going to have sort of what's called an improper fraction, which could then also be called a mixed number. So let's talk a little bit about these fractions and our strategy for today. For example, if I have simple little fractions like 1/3 and 1/4, part of the strategy today is to think about the value of these fractions. A good question to ask yourself is, what would be half of these numbers, okay? So if I have 1 out of 3 pieces, that's less than half, and 1 out of 4 pieces, that's less than half. So when you put those two pieces together, you would expect to get something that is a proper fraction with the total that's less than 1. Now, what about this? If I move on and I have something like 4/5, 4 out of 5 parts is almost the whole thing. And 1/2 is exactly in between. So when I put those two together, I'm going to end up with, or I expect to get, an answer, a sum that is greater than 1. And so when I do find my common denominator, which this is also the process that we've been using for the previous lessons by laying over the denominator number of pieces onto the other fraction. So we're essentially multiplying these two numbers together to get the new denominator. And when you add up all your pieces, you're getting something that's greater than 1. Now, 1 would be equal to 10/10. And so we see that it's greater than 1. It's that improper fraction with the real big head, and then it looks like it could tip over because it's top heavy. So what we're going to do today is we're going to take this improper fraction and turn it into a mixed number. And so I actually taught a lesson. I had lost my voice one year because this happens from time to time. And I taught the entire lesson without talking that day. And I just wrote the question, what is the relationship between these two numbers? And so when you're looking at 13 and 10, the relationship is that you can fit a 10 into 13 one time. Sorry about the pink that's bleeding through from the backside. 1 10 with 3 left over. And so we just did a whole bunch of improper fractions and changed them to mixed numbers. And so that's part of today's lesson too, since our sums will be greater than 1. And here's another one. Also kind of think about the size. They're going to be really close to 1. Like this is 1 and 1/24 is the answer. 25/24 is only 1/24 more than 24/24. So it's really, really close to 1. Our area models are going to be really detailed and kind of time consuming. And then another thing I'm going to ask you guys to look for is to think about when you're combining these fractions, again, the relationship between the numbers. And so old school parents are going to be like, yes, cross multiplying. How do you get an equivalent fraction when you don't have the area model? It's going to be to get into the practice of thinking about laying the fraction pieces over the other side. So if I put thirds over eighths, I get those 24ths. But I'm also multiplying this thirds by the top number. And so you can take that 3, and if you multiply it by both numbers, again, that 3/3, you would get 9/24. So I'm going to apply this in our lesson today. I don't want to go on and on with the notes because sometimes it's just easier to jump right in. Okay, so for the following problems, you will draw a picture. That's going to be your area model using the rectangular fraction model, and write the answer. Then when possible, write your answer as a mixed number. That's if it is an improper fraction. So let's take a look at our 2/3 plus 1/2 and make 2 little fraction models here. Remember, it's not art class, it's math class. So we want to work fast and just do your best. Now, if I have 2/3, then our first model will create 3 sections. That's what the denominator says, and shade 2. Okay, and then this fraction model should show 1/2, and we're going to show this horizontally, and you can shade either the top or the bottom, not both. And then you're going to take the fraction pieces from one and lay it across the other. So I'm going to make halves here and thirds here. Okay, now I'm going to take these and I'm going to show the equivalent fractions. So instead of having 2/3, now I have 4 shaded out of 6 total pieces. And I have 3 shaded out of 6. And again, you want to make sure your denominator is the same. Add those up, and I get 7/6. But I'm not going to leave this as an improper fraction that's top heavy with the big old noggin there. We're going to look at the relationship between 7 and 6. And remember how long time ago I said this is really a division problem? It's 7 divided by 6. So if 7's being divided by 6, 6 can fit into 7 one whole time with 1 left over out of 6. And this is your final answer. Now, how can that be? And I'm just going to show you with a different color pen. Now, if I have 4/6 here, I can take this piece here and I can shade it like that. So let's just say that's blue. And then I can take this piece and let's say this is highlighted yellow. And then I can say, well, that one can go there so that this is highlighted yellow. So then what I have is I have one whole, which is shown here with the whole number, and I have one left over that wasn't accounted for. Let's call this one the one that stands out, and that's left over, and that is the 1/6. And so if you look at the colors and the way I shifted them, that's what we're creating. We're creating sums that are greater than 1 or between 1 and 2 today. Okay, so I hope the color makes it helpful to see what's actually happening there. Let's do B. So 3/4 plus 2/3. This one needs to be vertically divided into 4 sections, shade 3. This one needs to be horizontally divided into 3 sections and shade 2. Then you lay these pieces across each other. So we're going to make thirds out of the 4ths. That's where our multiplication comes in. And make 4ths out of our thirds. And then we're going to show our equivalent fraction. Now I want you to look at the number we're creating. It's 4 times 3 for 12 pieces. Okay, because we took thirds and laid them over 4ths and 4ths and laid them over thirds. We're multiplying the 4 and the 3 to get 12. We have 12 total pieces, and you should too, so you can count them if you'd like. But I'm telling you, I'll have people count and they'll say, I've got 11 pieces. And I'm like, how did you get 11? Like, try again. So really rely on your multiplication so that you can get those numbers correct. Okay. Then to come up with your numerator, and I want you to notice how I'm going to cross-cancel and look, or it's just, we're not cross-canceling, sorry, we're cross-multiplying. So I'm taking 3 or thirds and putting them over the 3 pieces that were shaded, which means I now have 9 pieces that are shaded. You can count them if you'd rather. Don't make a mistake. And then for this one, we have our 8. And if you look, you can confirm that to cross multiply, we've got our 4 times 2 for 8. Now, when I add these up, what happens? I get 17/12, which is more than 1. Again, our sums are between 1 and 2. So how many are left over? Like I could show the 1, 2, 3 and move them over, and then you would have some that only fit in this model. Or you can just do the division. 12 fits into 17 one whole time with 5 left over out of 12, and that's your final answer. Okay, so you can do the coloring and the shifting if you'd like. But for speed's sake, we're going to go ahead and move on. All right, so this is 1/2 plus 3/5. So I have half here, shade 1 part, and then 5ths. I made this one kind of small, 3, 4, 5. And it's 3 pieces. 1, 2, 3 shaded. Okay, now you're going to take your halves and divide that one and fifths on this one. Try to be neat. Try your best. Now, when you have halves and fifths combined, that makes tenths. And I have 5 tenths here, and then I have 6 tenths here. And in the beginning, count them before you do this cross multiplying to double check. Yes, 2 times 3 is 6. Yes, 5 times 1 is 5. Add them together and you get 11 tenths. Don't leave it top heavy. If this is bigger, you're going to have to divide 11 by 10. 1 whole time with 1 left over out of 10. That's your answer. And then we'll move on to D. 5/7 plus 1/2. Make your model. And we have sevenths here. Oh, that's too skinny. 2, 3, 4, 5, 6, 7. And shade 5 of them. 1, 2, 3, 4, 5. Again, not perfect, but it'll work. And then half, top half usually. That's just what I do. And then you're going to flip-flop and make the equivalent fraction model over the top of each. This is going to be halves, and this is going to be sevenths. 3, 4, 5, 6, 7. How many pieces did you make? Remember, we're essentially multiplying the bottoms, so we have 14 pieces. Rely on the math if your model starts to look messy. How many pieces are shaded here? You can count them or do 2 times 5 for 10. Okay, so that it's going this way is how you're going to multiply the 2 times 5, and it stays on this side. Okay, and then this one is 7 times 1 going up that way to have the equivalent fraction here, 7/14. When you add 10 plus 7, you get 17/14. How many 14s can you fit into 17? 1. And the difference is 3. Remember to count on. Don't count 14. Say 15, 16, 17. If you need to use your fingers, use them. I know some teachers are super against that. I personally do not care. I say use what you need to. Okay, next one, 3/4 and 5/6. Now we have a lot of shading, so I'm going to try to make my models nice and neat. 3/4, remember, start vertically. 1, 2, 3, and 5/6. If you have an even number, split it into the half and then do the top half and the bottom half. So I have 6ths and I need to shade 5. 4, 5. Okay. Now for this bottom part, don't worry. I know some people will say, oh gosh, but I know how to have a simpler answer, and we'll get there. We'll get there. But for today, we're just multiplying. So 6 times 4 is 24. We're going to take the 6ths and lay them across here. In fact, after we make all these models with all these little pieces, that's why you guys are going to be desperately looking for another way to make this work, because this is a hassle. So you're going to want something simpler. So anyway, now I have 24 pieces. Hopefully you know your multiplication facts. 6 times 4 is 24. We have 24 pieces for each model. How many are shaded over here? You could count by 6 and go 6, 12, 18, or you could do 6 times 3 and get 18. You could count and do 4, 8, 12, 16, 20, or you could do 4 times 5 and get 20. Add across. I would start with the bigger. 20 plus 18 is 38. 24ths, now you find the difference. Oops, and I don't want to get too much into this space here. 24 fits into 38 one whole time, and then the difference between 24 and 38 leaves you with 14 extra. It doesn't say anything about simplifying, so we'll talk about simplifying later. I think it says simplify the simplify if possible here, but we're not going to worry about that just yet. We're only changing to mixed numbers. And then finally, 2/3 plus 3/7. 2/3, 2 out of 3, plus 3/7. So I need sevenths, skinnier, 4, 5, 6, 7. Remember, for 7 pieces, it's 6 lines. That's how it works out. How many pieces are we going to make when we lay these over? Almost forgot to shade. Don't forget to shade. We're going to have 21 pieces when we make sevenths here. 4, 5, 6, 7, and then thirds here. So remember, you're taking 3 times 7 for 21. And then how many are shaded here? Well, I took my sevenths and I put it on top of the thirds, so now I have 14 pieces shaded, 7 times 2. And I have 9 pieces shaded here. When you add 14 and 9, you get 23, 21s, or 21sts. How many 21s can fit into 23? 1. How many are the difference, or what's the difference between 21 and 23? 2 and 21. There you go. Okay, let's see if we can wrap up this lesson real quickly here. So solve the following problems, draw a picture, and write a number sentence that proves the answer, doing exactly what we did before. Simplify your answer if possible. So I'll show you about simplifying if we get even numbers. Penny used 2/5 pound of flour to bake a vanilla cake. She used another 3/4 pound of flour to bake a chocolate cake. How much flour did she use altogether? We've got pounds of flour and pounds of flour. Always look for your measurements to make sure they're the same. So we have our 2/5 and we have our 3/4. So we're going to make a model. Drawing a picture. And we have 2/5. So 1, 2, 3, 4, 5. Kind of awkward, but that's okay. 1 and 2. And 3/4 horizontally. Remember, cut it in half, then half the top, half the bottom. 3 are shaded. Take the 4ths and lay them over the 5ths. Take the 5ths and lay them over the 4ths. Don't do any additional shading. It's not about shading at this point. It's only about creating equivalent fractions. Okay, now if I have 5 times 4, I've created 20ths. How many are shaded? Here I have 8. 4 times 2, 8. How many are shaded here? 15. If you want to double check, check your work by adding. When I add 15 and 8, I get 23. And then I'm going to simplify if possible. 20 fits into 23 one time with 3 left over. And then I'm going to look back and see what I need to label it, and it's pounds of flour altogether. Okay, 1 and 3/20 pounds of flour altogether. All right, and now we're really just on to our last problem. Carlos wants to practice piano 2 hours each day. He practices piano for 3/4 of an hour before school and 7/10 of an hour when he gets home. How many hours has he practiced piano? Ooh, but also, how much longer does he need to practice before going to bed in order to meet his goal? So when we're talking about hours, we have to think about what fraction of the hour, how much is done, how much is left, what's the whole. So we'll talk about that. Let's take our 3/4 and our 7/10, and we're going to combine, which is adding, all the time that he has spent practicing. So make a model of each one. 3/4. I know, 10th is going to be fun, right? 3/4. 1, 2, 3. And then 10ths. So I'm going to first split it in half. Okay, you might need to make a bigger box. And I need 5 on the top. 1, 2, 3. 4 lines make 5 sections. And then 1, 2, 3, 4 lines make 5 sections. 7 of them need to be shaded. 1, 2, 3, 4, 5, 6, 7. Notice I didn't really color all the way across. I'll get back to it. There it is. Doesn't have to be perfect. Then you lay them across each other. Tenths is going to be 5 on the top. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now I have tenths, and then I have fourths this way. That's a lot of pieces. And when we can find a simpler or lower common denominator, we will, but for today, we're just multiplying. So we've got our 40ths plus 40ths. How many pieces are shaded here? 10 times 3 makes 30. How many pieces are shaded here? 4 times 7 is 28. 30 plus 28 is 58. 40ths. How many 40s can fit into 58? 1. Remember, our answers are between 1 and 2 today. Not that that'll always be the case. And then how many are left over? 18 out of 40. So it said in our directions to simplify if possible. Now, what I want you to notice is that the top and the bottom are even. And all even numbers are divisible by 2. So what you do is you take your 1 and 18/40ths, and I'm going to divide my fraction by 2 halves. And so 18 divided by 2, let's just don't forget about the 1, that stays the same. 18 divided by 2 is 9, and 40 divided by 2 is 20. And so that is how much time has been spent so far. Because I combined them, I got a common denominator, and so I have hours so far. The last part of the question is how much longer does he need to practice before going to bed in order to meet his goal? Well, if this is 1 hour and this is 9/20ths of an hour, then what's an hour? It's 20/20ths. So if you take what has already been practiced away from the 1 hour that he's working on, then we have what's left, which is 11/20ths. Click subscribe, come back again. We'll do more math, and we'll see you on the next video. All right, more to practice. Yay! And great job today. You guys are going to love Module 3. I love it. We'll see you on the next one. Bye for now.